back. In this video, I'll be discussing the calculator usage of number 72, the Ferris wheel type of questions. I'll also be discussing and how to enter things into the calculator, the types of question that we'll be asking or that are associated with this type of question using entirely your calculator. Okay, so I'll be switching back and forth on my screen. But do you remember this Ferris wheel question? We're spinning around in the Ferris wheel, right? And we know that we were, the diameter was 50, we were 5 feet off the ground and so forth. And we formulated this equation. And I think some of you guys are a little bit panicked. Am I going to have to come up with this equation? Yeah, but I think it'll become easier and easier. I want you to really think about and focus on the situation, okay? And I think that'll make it more, remember, make the situation applicable to you and think about how a Ferris wheel really works, and then I think you'll be able to figure that out, okay? All right, so let's go ahead and answer these questions. Let's actually enter this into the calculator. So I'm going to switch my screen, and we're going to go to the calculator. All right, so you can see the calculator now, right? I'm just going to play around with the screen a little bit. Let's enter this calculator. Let's enter this equation into the calculator. But when you're entering this into your calculator, be very mindful and think about how high does my graph have to be? Am I on radian mode? What's the amplitude? What's the midline? For instance, this case, let's start entering it. -25 cosine. And I'm going to put just a time sign here between that. -25 cosine, it's pi over 20, right? So I'm going to go pi divided by 20, or you can go like this. You can go ahead and press the pi button that you like to use. Pi divided by, oh, sorry, what happened? Oh, that's not right. 16? No, where did it go? Okay, I don't know what I pushed, okay? So let's start over. So I'm going to go to menu, open a new pagey, get a graph. Okay, sorry about that. -25, let's try that again. -25, ready? Cosine. I'm going to put a time sign there. Negative cosine. Parentheses. 2 pi over 40 or pi over 10, pi over 20, whatever you like, okay? Oh, sorry, pi over 20 or 10, 20, sorry, I think it's 20, right? Times, remember, and it's pi times 20, right? Pi times 20, x. It's not going to be, it's definitely not t. Even though we know that the x represents time, plus 30. So I want you to think about this. Do you know the maximum? Do you know the minimum? And if you do, then I think it's worthwhile if we spend the time before we press enter. You see how the graph is way up there? So what I would suggest you do is, that the midline is 30. Y equals 30. You know that the maximum, the highest it goes is 55 because you're adding the amplitude. And the lowest it'll go is 5 because you're going to go down 25. So what I'm going to do is I'm going to go to my menu. I'm not going to just mindlessly press zoom, 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 zoom. I'm going to go, min, max for this timeline. It doesn't matter because we're talking about time, right? But you want to try to kind of see, one period is 40 seconds. We talked about this, right? So we know for sure, maybe we want to go many different revolutions. So maybe 100, I don't know. Okay. Minimum, well, how low is this guy going to go? Not that low, right? So this is fine. Max, well, we know for sure that it's going to go all the way up to, what was it? It's 55. So I'm going to put up, let me be about 70. And then we see it pretty clearly. The window is extremely important. And I think it's better than you just keep mindlessly pressing zoom out or zoom out, zoom out, zoom out, okay? And you see now we have the function that demonstrates how our Ferris wheel is working. It starts here, it goes up and down, up. It goes in a circular motion, except now it's actually in a cosine format, right? So it looks like it's going up and down. And if you want to show the midline, you can actually do that, okay? So why don't we go this like this, and why don't you type in y equals 30? If you want to see the midline, you can press that. 30, right? Isn't 30 the midline? So here's our midline. Now, you remember the question they asked you is, how long after reaching the low point is a rider? After reaching the low point is a rider 50 feet above the ground. So they want to know 50, right? So you're going to press tab and type in 50 because remember, the y value tells you how high or low you are. The x values are representing time. As the Ferris wheel is spinning, where am I on the Ferris wheel is what this is calculating. So I'm going to put 50. Okay, so here are all the times that it's going to be hitting 50. Now, of course, what if I told you the full ride doesn't just revolve once, it revolves about 5 times, right? So that means you only see here in this case, 1, 2, right? So maybe you want to see more of the actual ride. So what you're going to do with the window setting is maybe go more. Oh, Y max, I'm sorry, not Y max, X max. Think about it. It's 40 seconds every revolution. So what if I want to go 5 times? I have to see about 200, right? So maybe about 300 times. You see how that's better? Because, oh, this guy's just a midline. I'm just trying to show you the midline. This guy is telling you all the values that's reaching 50 feet above the ground. Okay? And how am I going to do that? So what if I said the ride revolves around 4 times, right? 4 times. How many times does it hit 50 feet? So you're going to go to menu and you're going to go to analyze this graph. You're going to analyze this graph and you're going to find all the times that it's actually 50. So you're going to find an intersection. You're going to, oh, not intersection, sorry. You're going to find every time that it's 50. So you're going to go like this. Are you ready? You're going to go to menu, analyze, and you're going to go to, oh, yeah, it is intersection. You know what you're going to do though? You're going to intersection, but you're going to hit the graph. You're going to hit this cosine graph, and you're going to hit this graph here. So lower bound is, oh, what happened? What happened? Sorry about that. You're going to go menu, analyze graph, intersection, and you're going to go graph 1 and graph 2. And you're going to go lower bound, lower bound, and then upper bound. That's the first time it hits 50. You're going to do it again. You're going to keep doing it. Analyze graph, intersection. You're going to go, I want this intersection, this graph. Oh, I clicked it again. Sorry, I don't know why this is doing this. Intersection, ready? I'm going to hit this graph and I'm going to hit this graph. Lower bound is here, upper bound is here. You need to specify the lower bound and the upper bound because there are so many times that it actually hits 50 feet. So in the first, let's try again. Let's try the next one, okay? I'm going to explain to you. So let's go to intersection again. First graph, second graph, lower bound, upper bound. So I'm going to move that a little bit so you can see it better. So check this out. The first 2 values that we found, it took 15.903 seconds to hit 50 feet first time. Second time it hit was 24 seconds later. And the next time it hit was 55 seconds later. That means the third time that it hit it, it had already spun around once. So if I asked you when was the first time it hit 50 feet, you would have to answer 15.903 seconds. But you can see how this is done, right? Okay, so that's how you do that, okay? So use intersection function. Now, does it ever hit the ground? Does the ride ever hit the ground? No, it doesn't ever hit the ground, okay? So we can't ask you questions like that. When does it ever hit the ground? When it hits the ground, that means y equals 0. But in this case, it never hits the ground. Let's see what else we can ask you. Okay, we can ask you something like this. How long, oh, actually, let's check something. You know this point here and to here? How long should that be? That better be 40, right? So let's try this. I'm going to go to menu. Let's go to trace. Now, trace is a little bit tricky. So I'm going to go graph trace. But wait, no, I don't see any prompt. But you're going to press 0, enter. And what it does is it calculates at 0 where the Ferris wheel is. At 0 seconds, where is the Ferris wheel? And that's what it calculates. Let's press trace again. Trace. Now, at 40 seconds, where do you think it's going to be? Let's press 40. Graph trace x equals 40. And it's at 40 seconds, it's at 5. So you see how that's one cycle? That's one cycle of this cosine periodic function, okay? And that's how it works. At 80, where is it going to be? Of course, it's at the minimum again. I could ask you another question. Hey, analyze this graph. Where is the maximum? When is the maximum reach? When is the maximum reach? So you go to click on this graph. Oh, you're going to click on lower bound. And then you're going to click on max upper bound, and here's your max. Chicos, I'm going to move this around a little bit. So here it is. At 20 seconds, that's when it hit the first maximum, at 20 seconds. When was the next time it hit the max? So we're going to go to menu, analyze graph again, and maximum. I'm going to go this graph here. So I'm going to go lower bound and upper bound, and here it is. It's another 40 seconds, it's another 40 seconds until it hits a max, obviously, because it's the same period, right? Okay, so we've discussed, there's a lot of text on here. These points represent when it reached 50 feet, Okay, these points represent the maximum, and all we do is we press menu, analyze graph. Everything you ever needed. Minimum, are you looking for the minimum? Then you press minimum. Are you looking for the maximum? You press maximum. Are you looking for when the graphs intersected? For example, we were looking for when the graph intersected with y equals 50 feet and the actual cosine graph, and we press intersection. Okay, I think those are the most commonly used functions. Okay, we'll do the zeros in a second on the next video. So again, I'm sorry this is a little bit messy, but hopefully this is a little bit of a review, because I think in Algebra 2 you did do something like this with linear regressions and other kind of functions. Okay, all right, let me know if you have any questions. Bye.